Welcome to Unit 10 of Chemistry 101 at Goodwin College. Unit 10 deals with Chapter 9 in your textbook, and Chapter 9 in your textbook deals with a topic called nuclear radiation, also known as radioactivity. Before we begin Chapter 9, it's probably worthwhile to review a couple of things that we talked about much earlier in this course. So here is a slide that was actually presented to you in one of the first couple of units. And as a refresher, remember that atomic number, that term basically means the number of protons in an atom. And I showed you this earlier, much earlier in the course, and I asked what type of atom is this, and here we are using the convention of having this red circle mean a proton. So this particular atom has one proton in it. You can pause and think about that to try to refresh your memory as to what type of atom it is. And the atom that has one proton, or the atom that has an atomic number of 1, is a hydrogen atom. So that's a hydrogen atom. Then I showed you another cartoon version of an atom. This one has one proton and one neutron. And I asked the same type of question. What type of atom is it? Again, this is also a hydrogen atom. It weighs twice as much, or its mass is twice as large as the atom here on the left. But it is also a hydrogen atom because it has only one proton in it. Then I showed you a third atom. This atom has one proton and 2 neutrons. And again, I said, what type of atom is this? And it turns out that this is also a hydrogen atom, because the feature that makes atoms a type of atom that you're talking about is the number of protons that they have. So each of these 3 atoms, the one on the left, the one in the middle, and the one on the right, they all have one proton. Because they all have one proton, they are all hydrogen atoms. Now, you can basically say that the middle one, the middle atom here, is heavier than the atom on the left. And so you could call this heavy hydrogen. And you could say that the atom here on the right, this hydrogen that I'm circling here, is even heavier than the 2 on the left. And so if you wanted to, you could call this atom here on the right heavier hydrogen. These 2 atoms, the one in the middle and the one on the right, they actually have more formal names that you don't need to know about. But what I mentioned earlier in the course is that all of these different versions of hydrogen are called isotopes of hydrogen. And I basically said that isotope means an isotope of an element. It means that you're talking about a version of an element that is either heavier or lighter than other versions of the same element. So that's all that isotope means, and we're going to talk about isotopes for the rest of this unit. So just to emphasize again, this is an isotope of hydrogen, this atom here on the left, because it is lighter than these other versions of hydrogen. And this middle atom is also an isotope of hydrogen because it's heavier than this one and it's lighter than this one. And this atom over here is also an isotope of hydrogen because it's heavier than the other 2 that I'm showing you here. So each of these individual atoms is one particular isotope of hydrogen. And the other thing that I emphasized previously in an earlier lecture is that all elements can have isotopes. It's not just hydrogen that has isotopes. As an example, this is an isotope of carbon. You can tell that it's carbon because it has 6 protons, these 6 circles in red here. In this particular case, if I asked you what is the atomic number, well, if you remember from the previous slide, the atomic number is the number of protons. So this atom's atomic number is 6 because it has 6 protons. If I ask you what is the atomic mass of this particular atom, which is a carbon atom, if I asked what's the atomic mass, you can pause again, try to refresh your memory about this. And the atomic mass is all of the protons and neutrons added together. So this particular version of carbon has an atomic mass of 12 atomic mass units, or if you wanted to use the more biological unit, you could say it has a mass of 12 daltons. So this carbon has an atomic mass of 12, and all carbons have an atomic number of 6. This is a different isotope of carbon. This is a different version of carbon. It's still a carbon atom because it has 6 protons in it. But if you look, it has 2 extra neutrons down here. So the atomic number is the same. The atomic number of this carbon atom here on the right would still be 6, but the atomic mass would be 14 atomic mass units, or 14 daltons if you wanted to. And because these are different versions of carbon, you basically say that these are different isotopes of carbon. This carbon over here on the right, when it's spoken by chemists, when chemists are talking about only this version of carbon that has a mass of 14, what they will say is they will call it carbon 14, which is to try to distinguish it from every other isotope of carbon that does not have an atomic mass of 14. So if you wanted to talk only about this version, this isotope of carbon, you would call it carbon 14. And if you wanted to only talk about atoms of carbon that had an atomic mass of 12, like the one here on the left, you would call this type of atom, you would call it carbon 12. Now, it's a little bit of a pain to write this out, so chemists have their own shorthand, which I believe I showed you previously, and the way that you describe specific isotopes of an element is that you write the symbol of the element and then you write the mass of the isotope as a superscript to the left side of the symbol. So if we were talking only about carbon atoms that had a mass of 14 Daltons, the way that we would write it probably in a text is we would write the atomic symbol for carbon, which is a C, and then we would write a 14 as a superscript to the left. And this basically means we are only talking about carbons with an atomic mass of 14. We're not talking about any other version of carbon other than that. If we wanted, and this is the mass number that shows up in the upper left here. If you wanted to talk exclusively about this type of atom, about only carbon atoms that have an atomic mass of 12, then you would write the letter C for carbon, and you would write the number 12 as a superscript to the left. And this basically says, I am only talking about this isotope of carbon, not talking about any other versions, not carbon 14, not carbon 13, not carbon 11. I am only talking about carbons that have a mass of 12 Daltons. Sometimes, and we will see this in this chapter, this is something that I probably didn't show you earlier. Sometimes people will write the atomic number as a superscript to, as a subscript to the left of the symbol. And so this 6 here basically means that we are talking about an atom that has 6 protons. And this 6 here also means we are talking about an atom that has 6 protons. And the convention is to write the number of protons or to write the number of positive charges that an atom has as a subscript to the left side of the symbol. Now you might wonder, well, why do we even have to bother writing the 6 here? Because I know just by looking up in the periodic table that all carbon atoms have 6 protons. So this seems to be a little bit of a waste of time to actually write the 6 out, because the number 6, the number of protons that carbon has, is already implied just by writing the symbol here. We know that all carbons have 6 protons. And that is perfectly true, and that's perfectly valid. The reason for writing it down here is that it's used as a convenience when doing certain types of calculations that we will do in the rest of this unit. So you don't actually need to write the number 6 down because it is implied by the letter C here. But we do it just because it makes certain calculations easier later on. So the atomic number, or the number of protons, or the number of positive charges in an atom is very often written as a subscript to the left of the symbol. So that's it as far as a review for past lectures is concerned. That's the background information that you're going to need for this unit. In particular, you're going to need to be able to read this type of symbol and know that this means an isotope with a mass of 14 and an isotope with 6 protons or 6 positive charges.